going to present my lifelong research. It's called Life Cycle Engineering for S4 Systems. They have to be with social, sustainable, sensing, and smart. And I do hope that you enjoyed this presentation. I will talk for about 40 minutes, and then I will leave 20 minutes for questions. First of all, can we project? That's my first book in 1999, and it was a handbook of life cycle engineering. So I edited the book with a lot of colleagues to talk about the idea of why is important life cycle engineering in the development of products, manufacturing systems, and also enterprises. Can you reduce the volume because it has a very strong noise? And that's my latest book, where we put with my PhD students and my postdocs and one of the professors of the group, all these ideas of creating exactly life cycle engineering, but based on what we call it sensing smart and sustainable systems. So what I'm going to do with you is I'm going to give you some basic ideas and basic concepts so we can understand what we are really doing research about it, okay? So first of all, the definition of life cycle engineering. Life cycle engineering is a concept of what we call it system of systems, where what we have to do is really, when you want to develop a new system, you want to go through what we call it a life cycle. Anything that you create, a product, a process, a manufacturing system, a company, has to go through, okay, again, is summarized, you know, ideation, conceptualization, design, and creation. And when that's the life cycle of anything or any system that we have around us. But also, when we want to do it in a different way, and there is a concept of simultaneous engineering or concurrent engineering, what you have to do is to do products. Concurrently, you have to do process development, and concurrently, you have to do manufacturing system development. So that's very, very important also because when I do a design of a product, and if I don't consider anything about the manufacturing process, then I can design a product that is not manufacturable. And also, if the process doesn't take into consideration the manufacturing capacity that you have available in the manufacturing system, then it's very difficult also to go and realize and fabricate that kind of product. So what we do, or what we have been doing in the last 20 years, is trying to develop a reference model to do that. So we have, through the life cycle of a product, the life cycle of a manufacturing system, and the life cycle of course, a factory where you want to produce and manufacturing the product. And as I said before, when you are doing product development, product ideation, you have to start thinking about what type of components do you have, what kind of materials you are going to use, how you're going to do the manufacturing process, and how you're going to produce it in a fabric, in a facility, in a manufacturing facility. And the same goes for everything. So you have all the time to start thinking that you have to start thinking that everything has to be done concurrently, okay? So when I do the design of the product, I have to start thinking about how we're going to manufacture in the process and how we're going to do it in a factory. So do that all the time simultaneously. And that's improved a lot the type of product that you want to produce. And that's why all these techniques of design for X, design for manufacturing, design for assembly, design for sustainability comes around, because then you can really take into consideration all the restrictions how your product is going to be performing in real life, and then you incorporate all these rules when you are doing the design. So design for sustainability, for example, which is a very important aspect of what we're doing. When I start doing the design of a product, I have to start thinking on the sustainability of such a product. Or when I design a manufacturing process, I have to start thinking of the sustainability of that manufacturing process. And again, when I have to create and design a factory, I have to start also thinking how this factory is going to be and become net zero. Okay, so that's very, very important. So this is a really important concept. And I'm going to talk about at the end, what is the future of our research on this area. So that's the concept of life cycle engineering, you know. You have to take into consideration all these aspects while you are doing the design or creation of a product, of a manufacturing process, and a manufacturing system development. On the other hand, we make a definition of what is a S4 system. Okay, a S4 system has 4 attributes: social, sustainable, sensing, and smart. And what is really important when we talk about social is that a new way of how we are developing things in the world is by considering this idea of collaboration, also of what we call it a mass open innovation. We work together with other people and we ask other people to help us in the design and development of new products, process and manufacturing system. And also we talk about crowdsourcing of ideas. The best way to create something is to ask the user, to ask the customer about what are their needs. And when you incorporate that into your system, then possible, okay, I'm not saying it's sure, but possible you are going to create a product that is really useful with all these characteristics. Once you have to ask the people to do this idea of how are their needs, then we do what we call a human-centered conception, creation, usage, and disposal. So we incorporate all these attributes to the product, the manufacturing system, and the manufacturing process, so you can really incorporate this, that's why we call it a social aspect of a product. Then you have to think about sustainability. And when we talk about sustainability, we are talking about economic sustainability, we're talking about environmental sustainability, and we talk about also, of course, social responsibility. Anything that you create has to take into consideration all these three elements of what is sustainability: economic, environmental, and social responsibility. And of course, if you do a collaborative and mass open innovation crowdsourcing development of anything, then you can really create a more sustainable type of system. I talk about a system because a system is a set of entities that are aligned to achieve certain goal, okay? And when we talk about more technology-based things like sensing, so now when we talk about sensing, we are taking is to incorporate into the system elements that allows them to sense the context aware, and also to send and evaluate the foresight. Because if you have data, you can really foresight or forecast what is going to be the behavior of any system. And of course, when we talk about the smartness, then we say, well, it has to be intelligent, it has to be adaptive, and it has to be interconnected, so you can really collaborate with other elements of collaboration and integration. So that's our definition of a system that has the attributes of being social, sustainable, sensing, and smart. So now we understand what is life cycle engineering and what is a S4 type of system. Now, when we talk about the system, then we can really think about products, processes, manufacturing systems, and of course, enterprises. So we can apply exactly the same type of concept to these four types of systems. All the products that we produce and create, all the process that allows us to produce those type of products, all the manufacturing system that allows you to run those manufacturing processes so you can really create and produce the products, and of course the companies and the enterprises that allows us to really run and create this type of new also entrepreneurship, and that's very, very important. And you are going to see how we have been applied this to a very specific example, which is a micro machine that have been developing for the last 20 years. So it's a project that we have really created now different types of versions of the project, but you can see at the end a video of how it looks like right now after these 20 years of research. So let's go and say that also, when I'm talking about the human-centered rapid development process of S4 system, is we have created also a process that allows you to work with the students and with industry people to take this idea of evolution is based also on the concept of system thinking, but what we have to do is try to say, well, when you want to create a life cycle of something, you have to imagine the product, you have to conceptualize the product, you have to do the design of engineering side, and you have to do creation. Remember, that's the life cycle of what I already explained. So what we have put it together here is a set of methodologies and concepts that allows you to do it that more rapidly. We have created what we call it the rapid product development life cycle engineering approach. So we do a lot of techniques that allows us to do in a short time term the development of all these type of systems that we have already available for that, okay? So the idea is that you go in these cycles and then you can really create whatever you want in terms of the S4 types of systems. So let's go and explain that also all this framework allows you to select certain technologies which are computer-aided technologies to sustain and enable a faster development of any of these activities and help the engineers to do their job in a rapid way. So we have also created a set of technologies like computer inundation, knowledge-based engineering systems. Of course, we have been using a lot here. We are engineers, CAD, CAM, CAP, and some other simulation tools and so on. So we really can also use this framework to put together all the different types of tools that we can really use to support the development of these type of systems. And of course, there is a lot of areas of research of how we can develop this type of platforms to support the development of S4 systems. So we were talking with Alex before to say, let's go and create and develop this platform, rapid development of materials. And I believe that we can really use also the same concepts to create these new type of platforms. So let's go and talk about an example so we can really see how we are doing this process. So I'm going to first start with the product development. And I said I will have different types of tools that allows me to create different types of concepts. My area of research has been always machining or machine design. So we have been creating this, what we call it, the micro machine with multifunctional capacities. So we go through a process of analyzing what are the requirements for the students to really use this type of machine, or the engineers to use this type of machine. We do an analysis of system thinking. We use a matrix, morphological matrix, to evaluate alternatives, and then we end up with a version of a micro machine. A micro machine is a small machine that does and performs different types of processes. And of course, this allows us to create this type of products. So when I talk about, well, first taking care of the sustainability, I have to evaluate what are the impacts of all the different elements that I want to include in this micro machine, then the economics, so I can really create and select different types of parts and components that are at economic scale, and of course the social part of it. So when I were working with people who's going to be the users, I can really create a new machine with all these elements. And again, anyone who is a mechatronic designer knows that the elements for a mechatronic design is what you want to control, what actuator you want to put in sense, what kind of sensor, what kind of control loop you want to stir, and then what kind of algorithms for controlling is that you have to implement. So that's how you do the sensing and how you do the smartness. So if you go and do a design of any mechatronic systems, you can use exactly the same type of methodology to create machines, pump controllers, electric machines, or whatever you want to do using this type of model as a reference. So let's say that also what we have done before is that we have created taxonomy so we can evaluate products. In that case, it's the first version of our micro machine, which was something that it was really not flexible and not very sensing and not very smart, but at least we created that machine. We did an evaluation of the sensing, smart, and sustainable capacities. We created taxonomy to do that and the evaluation, and then we did a new redesign of the first approach of the machine to a second approach of the machine. So you can see the difference. I don't know if this have a laser, but it doesn't work. So you could see it seems like it's very tough and very unique machine, but then you can see on the second type of, I say, version of the machine is more flexible, it's more nicer, it has incorporated more aspects of the design, and also has incorporated more functions like laser cutting, 3D printing, and so on. So the idea is also to always use this methodology so you can really also improve the design of any type of product that you have into a design that has more activities of sensing, smart, and sustainability, which is also very, very important. So we use this as a systematic methodology. It's also called an approach of system of systems. So you start thinking everything as a system, and you develop systems that really incorporate all the attributes that are required to have that as a reference. Then, when we talk about the manufacturing process, in our understanding of the manufacturing process is that it's a system that incorporates, a material, then it transforms the material based on controlling certain variables of flow, pressure, temperature, level, vibration, noise, and so on. And then at the end of this process, you have a part of a component, you have some scrap, you have some emissions, and of course, you have information about how the process was performing. To do that, also you have, and being sustainable, you have to work out and try to control the energy, the consumables, water, air, oils, and also the sensing and smart control, so you can do more what we call it intelligent control. So any system, any process, again, in this case, a manufacturing process, can be modeled in this way. And we are doing that project with Michelle in a company called Bocar and trying to capture and reduce it. Well, first capture the CO2 emission of a process. It's a foundry of aluminum, injection molding aluminum. And we use exactly the same process. So it's the same approach. So we can really start controlling in a better way the variables. If you can control the energy consumption, the water consumption, you incorporate control process algorithms based on artificial intelligence, and also you control the scrap and the emissions, then you have a more sustainable process, okay? So then, as you see, I'm applying exactly the same theory, but now to manufacturing process, okay? Now, let's go and see. Of course, when you develop a manufacturing process, you have to also take into consideration, first, what type of process you want to undertake, and the base of that is materials. If you don't understand materials or sustainable materials, it's very difficult that you can really pursue in the development of a good manufacturing process. Once you do the manufacturing process selection based on the product that you want to create, based on the materials, geometry, tolerance, and surface, then you do value stream mapping so you understand what type of activities you have to perform in order to create and perform that process. Then you do cost analysis for the economical point of view of the process, and then you have the manufacturing process specification, so everybody understands in a factory how you're going to create that type of products. Again, when we have this, I can say, I'm going to produce this type of product, and this type of product has to perform and take a lot of the part of components, and they start to say, what are the attributes that I have to pursue on the process so I can really reduce the cost models, I can add the functionality of the process, I can do the configurability of the process, and all these type of things. So when I create a process, I can take in consideration all this information, and I can see what type of process I have, and I can simulate that process so I can really have a better understanding of all the elements that have to be considered in order to have a really, really, really complete manufacturing process using all these ideas of being, again, sustainable. Of being, again, of being sustainable, of being sensing, and being smart, okay? All the time, you can use that kind of attributes, you know, the one I already explained here, you know, you have a taxonomy. Again, I create a taxonomy for products, and I create a taxonomy for processes. So you really can have in consideration all these elements to really drive the design of a smart, sustainable, sensing manufacturing process. And of course, if you do this as a loop and you use different types of techniques for simulation and optimization, you really can have a better manufacturing process with those attributes. Of course, we have 4 or 5 levels of being smart, sensible, and sustainable, and the evaluation allows you to really also work in specific elements so you can create a more sustainable product or a process, or a more sustainable, more sensing process, or a more smart manufacturing process. And we have done this also with companies. So usually what we do, we go to a company and we apply exactly the same approach. We go and do the evaluation of the company from the manufacturing process point of view, and we say, okay, let's go and see how do you do the operations. And then we realize that they are not using any sensing for emissions, or they are not using any sensing for energy management. That's the case of the company we're working right now. So then you do an evaluation on the process that the company is running. Then you say, well, sensing is 1, smart is 1, sustainable is 2. Then based on that, what you can do is really analyze using the taxonomy and do all this process approach, and then propose how the company could improve the manufacturing process to become more sensing, more smart, more sustainable. That means that if I want to make it more sensing, then I have to incorporate more sensors to the process. So I can control in a better way the variables of the process. If I want to do it more smart, I can analyze how is the control process loop. If it's an open loop, then I don't have any feedback. So I have to create and design a closed loop so I can really control better the process. And of course, I can do an evaluation of sustainability in terms of measuring all the variables of CO2 emissions, energy management, water or consumables production, uses, and so on. So I can really improve in the company how they can really do and have a more sustainable, sensing, and smart manufacturing process. And that's very important because you have to always to go to a company and do this in a way that you can really do it in a systematic way. So the output and the outcomes of any improvement are really something that you can really achieve using this type of systematic methodology, okay? Is that clear? Okay, now, what is next? So I'm done the product, I'm done the process, and now I have to do the manufacturing system development. And the manufacturing system development, we have created 3 different types of approach. One is what we call it the product transfer. The other is what we call it the technology transfer. And the last but not least is a new facility design. I don't know if you know, but usually in the automotive industry, before the newest strategies, every time you have a new vehicle, a new car, you have to create a new complete facility. So you design facilities from zero. But now what you are doing is you are incorporating and doing more technology transfer. So you have a new facility, and then you use that facility that is already fabricating some cars, and then you just incorporate new technology so you can really able to produce more cars with the same investment. And of course, sometimes you have to do product transfer. That means outsourcing of the product. So we are also tackling that type of approach. And let me talk about some examples of what we have been doing with some companies. Again, the manufacturing systems is, again, a system that requires to be controlled, the equipment, the cell, the line, the shop floor, the robots, the material handling systems, with an approach of sustainability, sensing, and smart. So you have an actuator, a set of actuators, you have sensors, you have a smart module, you have a connection to the IoT, and then you have the interface so that people can control the manufacturing system. Again, it's system of systems. I can really use exactly the same approach to achieve my goals of having a more social, sustainable, and sensing and smart system. When you have to design a manufacturing system, you have to go to different aspects. You have to understand what product you want to manufacture, what process you are going to use. We already did that in the previous stage. And then you have to start thinking about what is the intelligent manufacturing system strategy, what kind of machines you want to use, what type of tools you want to use, what type of manufacturing materials handling systems you want to use, jigs, fixture, and so on, and then all the types of manufacturing elements so you can really run a factory, right? So what happened with my approach? So usually what I go to do is that I can really, when I want to manufacture a product, I can really go to a factory that is already running, and what I do is say, if they have the capacity, I can only take my product and my process, do a specification, and then transfer that to the facility that is already producing products. So what I do is I do the product transfer, the outsourcing. I find the supplier that has the machines, that have the resources, and they can manufacture in my macro machine, okay? So I don't have to implement a factory. I can really outsource everything, and I have a supplier to do that. Sometimes, what you want to do is really to try to, if you have an element in your product that requires a very specific type of process, what you can do also is you have to identify what type of technology you have so you can do the manufacturing process, and then ask the supplier to incorporate that technology into the factory. So you are able to produce that specific component in that facility. So what I transfer to the company is a specific technology, a machine, a CNC machine, or a specialized machine or manufacturing process. I train the factory to do that, and they do that process inside the factory. But I don't have to create a new facility. I just help them to incorporate new technology so they can really run that type of process in their facility, okay? Last but not least is what we call it a new facility design. So if I want to do that, then I have to say all the types of components I want to produce. I do a process for manufacturing system design. I create my factory, and then I have a complete factory doing this, okay? So there are these 3 important approaches for manufacturing system development. Either I do an outsourcing of the part and component to a supplier, or I identify a certain technology that I have to incorporate into the factory so they can really run that process and make my product, or I decided to create my own facility and I create everything, Well, or you have the capacity to do in this case, the macro machine manufacturing system facility to do and perform this type of product. Examples from industry. So let's go and say the product transfer. We did a lot of work. In 2000 was a year when there was a lot of manufacturing production process made in the United States that they wanted to looking for suppliers in Mexico. Exactly the same what is happening right now, you know? With all the strategy of the United States that they want to bring back manufacturing to the United States, now we're exactly at the same type of process or opportunity. We want to do the manufacturing at the low cost, but near shore. That means very close to the United States. So how do you do that? We usually, we were trying to find customers in the United States and also Europe. They were bringing their drawings to us. We were analyzing the drawings. We were doing the manufacturing process design. So we understand that that type of component has to be turning and it has to be milling. And then we identify what type of machine do you require so you can really do that kind of process. We identify the supplier, we specify the quality specification, and then we have the product made in Mexico. That's what we have to do right now, you know? We have a lot of work on doing that. Working with customers in the United States, trying to identify what type of components they want to bring back from India or from China. We have to do the analysis of the process, of the product, the specification, the quality assurance, and so on, and then try to identify what kind of technology we can really run and perform in Mexico so we can produce that type of things. You know, that's an aerospace component. It's a jacking pod, so they can, when they do the maintenance of the airplane, they use that to lift up the airplane. So these kind of things we done. Now, of course, we have to have a special treatment on the power and everything. That's how we do product transfer, and I think that right now we have a project with some companies to help and to bring back manufacturing to the United States and Mexico. Second type of specification, technology transfer. You have to do, this is a joke for the automotive industry. Once you identify that you want to manufacture that type of process or product, then you have to identify the technology and you have to buy the technology. So you do the tamping and reaming of that machine. You buy the machine, incorporate that into the factory, and then do ask and train the people to run that in the factory. So what I do is that I understand the product, I understand the manufacturing process, and then I understand what type of technology you have to be using in that factory so that I can incorporate that technology into that factory. And then I train the engineers, the workers, and everything so they are able to produce that type of product. That's also very important because we know how to do the manufacturing process. We know the characteristics of the manufacturing process, but also we have the knowledge of running that type of manufacturing process in very specific facilities. So that will be the other type of technology transfer. And you can do it with every type of technologies. If let's say that the group of Alex Elias identify a process of 3D printing that has to be done so they can incorporate to a manufacturing facility, then we do that, we do the training, we do the experimentation, we are able to produce the product, and then say, you have to buy this machine. Because that machine will allow you to be more competitive, for example, right? So that's the kind of thing we can do as in our institute. We can really help the companies to incorporate new technologies, new manufacturing technologies, so they can be more competitive regarding other competitors around the world. Last but not least, the facility design. Of course, you use a model that we develop, and then you do the design, do the manufacturing process, the strategy of what type of machines have to use, and then you are able to produce that type of product, and that would be something that we said, I have to go through all this process, which is a very well-structured manufacturing process design and facility design. So we understand the components, we understand the manufacturing processes, we understand what type of process and what type of sequence of all this process have to be done. We do the specification of what materials, what type of worker, what type of means, what type of process and manufacturing KPIs we have to process. And then we're able to design in the facility, and then we have simulation tools to really design the complete facilities. And then we help the company to create new facilities. We have done that also with companies. We have helped them to design new types of facility so they can really produce new products. And of course, usually they are worried about the volume of production, the takt time to produce, so they can really achieve what the customers wants to do related to that type of facility and manufacturing process. And we, of course, what we have been also working with, again, It's the same macro machines. We say, well, now everybody's talking about cyber-physical systems, right? What is a cyber-physical system? Really is something which is real, that's our macro machine. Then what you do is, because of that machine is a mechatronic product, you have sensors, you have RFID, you have embedded system, you have electronics, software, and so on. The idea is to try to create a virtual world where you have exactly the same real machine, but into virtual models. So you have digital models on the geometry, on the structure, on the material, on the operations, and so on, and you can run that model to evaluate the performance of your product. And when you do the evaluation of the product in a digital world, you can start feedback into the real world, and then you can improve also the design of the product. And also you can improve the operation and the performance of the product. And you can also have the digital model running, the physical model running, and you can also forecast the performance or forecast the problem they are going to have with maintenance. So this idea of having now digital twins running together with the real systems allows you to really improve the operation and also capture a lot of information. So you can, in the unit design, you can use all this data that you are collecting, so you can really then, of course, improve the design, improve the operation, improve the performance of the real physical components. This is very, very important. Again, this is about this micro machine that we have, to do the center drill, lathe, laser, 3D printing, and so on. I'm going to show you now a video of that machine so you can see how we have been achieved this incorporation of what we call it, this life cycle engineering to a specific product development on a complex product, which is a machine, right? Run the video, please. Nope. ¿Puede o no puede? No quiere, no quiere. Ahí va, ahí va. Pero quiere, como que sí quiere, pero no quiere. Sí lo probaron, ¿verdad? Okay, go back. Now again. That's Mexico City campus, our lab. So as you can see, we are able to create everything. No? If we use exactly the same approach to do product development, manufacturing process development, facility development, we can create anything we want. But again, it's very important that we have this way of thinking, design of systems, and use exactly the same approach to have that kind of new technology that we can produce. So what is next? So right now we have already worked with product, process, and manufacturing system. Now, because we are in a materials advanced institute, we want to begin working also with materials development and try to create the platforms that allows us to do that type of things. We want to create a platform so we can really capture the user needs, functionality, and performance, try to have certain tools and methods to do the molecular structure and synthesis, also, of course, doing the materials engineering design, and then finally the prototyping of the products. So we have to work on that so we can really have this approach, and we have a very systematic way of doing things. As you were seeing in the video, we have a platform already. We call it the knowledge-based engineering platforms for machine design. So we can incorporate new types of process. I mean, we were working this 2 weeks ago with some students from the Tecnológico Nacional near our campus in Tláhuac, and they were using the micro machine to put other types of process and other types of products. So they use the same platforms, so you can really use the macro machine to incorporate new type of process. For example, they were trying to do a design of a micro machine that allows the dentist to do the, the molds for the cavities, right? So you can really, use that as an important aspect so you really do rapidly this process development. And of course, we want to go into what we call the supply chain development because, as you know, during the pandemic, one of the major problems that we have is the cutoff of the global supply chains. So we have to be able to create the capacity of building, again, this type of system locally, at least in the nearshore area of Mexico, United States, and Canada, and we have to be able to produce and manufacture almost everything, from materials to equipment to products. So that's going to be the challenge for us in the next five years. Okay, so that's basically the idea of the new future of research using exactly the same approach of life cycle engineering, extending this model for materials and for supply chain execution. Well, thank you very much. If you have any questions, I will be happy to answer them. And it's just in time. Thank you. How are we going to, should I, a microphone? Yes, we have a microphone.
Yes, thank you, Dr. Arturo, for this interesting talk.
Yes.
So we have two questions from Jorge Isaac Chaires. The first question is, is that possible to introduce blockchain tools based on machine learning in parallel to the methodology to perform the assessment of the final product?
Yes, of course. I didn't go into any detail, but blockchain is a tool that we can really incorporate very easily. We have just to find out what functionality we want to achieve using the blockchain approach. Thank you, Jorge. Yeah.
Okay. The second question is, in terms of sustainability and product quality, reinforcement learning seems to be a natural way to close the loop at an external level to perform recurrent incremental optimization. What is your opinion on that possibility?
Well, remember that when you do a product development or manufacturing process development, you have to capture data and performance data, so you have a loop, and you use design of experiments and robust design and failure mode and effect analysis, so you can really incorporate that into your loop of product development. So it's a natural way. I didn't go into any of the details of how we can really go from version 1 to version 2 to version 3 to version 4, but that's the kind of things we are doing. I mean, now we're in version 4 of the micro machine. So, and we incorporate exactly that. All the data we collect on the performance of the machine when they were doing laser cutting or milling cutting or cutting, we capture that information in the design of experiments and then feed back into the system so we can really improve the product. Yes?
Doctor.
There is a question here from Alex.
Okay.
Thank you, Dr. Arturo Molina, for your nice presentation. We really enjoyed it. I have some curiosity and comments, and I'm pretty sure that you can help us in that. I was thinking that sensing, smart, sustainable, and social is very important, but also we need to add maybe an additional S. It could be maybe science.
Science.
So what are your thoughts about that?
Well, science bases everything, and we have discussed this for long, If you don't have science, you cannot have the other things, Engineering is the application of science. So I will say, well, if you want to really create new type of products or process and everything, you have to begin with science and with the understanding of science and all the mathematics that comes from it. So I am a strong believer that science is everything. So is the base of the other things.
So in the future, we're going to see the fifth S over there?
Sure. well, let's go and develop that together. Science and then social and the rest.
Yes, it's very important, science.
Yes.
I have a question. This is an important reflection that I want to do with you, since you are an expert on this area. You know that nowadays nearshoring is bringing a lot of opportunities to Mexico. Specifically in Mexico, we know that the exports is reach about 80 or 90%, and everything regarding to this 90% is about manufacturing goods. So it seems like in Mexico, it is a country that really focuses on manufacturing activities. And there are a lot of, because of the new nearshoring and because of the pandemic situation, that there is a lot of companies that wanted to come here to Mexico. So I would like to ask you, imagine that, I'm pretty sure that some firms should be watching your presentation. What would be the strength and weakness that our industry have here in Mexico? And what would be your recommendation for those abroad firms that wanted to come to our country?
Okay. First, I believe that we missed the first wave of manufacturing when in 2000 to learn more about how we can do more basic engineering or more type of Mexican type of products, as the Japanese and Koreans and Chinese did. They took advantage of being a strong manufacturing countries, and they learned how to create their own products, and they create their own products. So we are missing that in Mexico. We have to be able to create our own products because we have all the knowledge. We have the manufacturing process knowledge, then we have to bring that manufacturing knowledge process into the engineering part and the design part. So I will ask, a lot of the companies that start bringing their capacity for product design, product engineering, creativity to the facilities here in Mexico, because if you work together close with manufacturing, you can really do a more rapid development of products. That's what will be a good asset of Mexico. We know how to manufacture products. Now we have to be able to create and design new type of products. And I will ask more companies to really bring the capacity here, because they will be able to really satisfy more rapidly the market. And the cycles will be shorter, and it will be easy for us to really scale up new products and do be more flexible, more competitive in the creation of new products.
Okay, thank you.
Thank you, Professor, for the presentation. It was very nice, very useful. With this theory, theory is always beautiful. I like that. With this theory, we can work in a lot of different stuff. For example, we can develop new products, new processes, or improve the already existing ones. But I think something very important from my experience, and I think from your experience too, what is the biggest obstacle that biggest and most common obstacle that you have found when trying to apply these methodologies to a real process or product? What is the most common obstacle that you already have with industries or partners working with this?
They want to have an answer very fast. So they don't want to take the time to do it systematically. So they want to rush everything. So you want to rush everything, then you miss important aspects of experimentation, analysis, mathematical modeling, and I believe that that's the weakest point from the industry. They want to do a lot of things without formal, systematic approach. And that's the wrong thing, because then I was working with a company, I don't want to say their name, and they wanted to develop a new type of machine. And we were doing this approach for them, but they really want to do their own thing, you know? And at the end, they couldn't do the machine because they were missing a lot of data or experiments and prototyping, and we catch them with our system. So we designed the machine, it worked, and they couldn't do it, and we did it. So you can see that that's a problem. We don't have this very systematic scientific-based approach for product development, and you have to have that approach. There's no way you are not going to do it in another way. I mean, and that's time consuming.
Yeah, of course. I think, yeah, as you just
well,
said.
you know that. I mean, we're working with the company now, and they don't have the data also, you know, that's another problem.
I think it's also because of the customs. Not everyone, but a lot of the industry people that are working all their life industry are very used to some very specific way of work. Then when we try to apply these tools, maybe they doesn't have the same approach, and it's where these different customs or ways to work collide that we have maybe this problem sometimes.
But you have to train them. I mean, you have to have time to spend them, and they can see the benefits of doing it that way. I mean, Alex has been done this with the industry. He said, let's go and train them. They let them know how is the scientific approach, how it's important to have data, how it's important to have experimentation, and you have to take time to do the experimentation, and you have to train them, no?
Okay, thank you so much, Professor.
Yes.
Okay, we have one more question from Dr. Eliana. What are the important technology enablers of Industry 4.0 in a smart factory?
Wow. Well, I could say that all, but I would say first you have to start with sensing. So when you want to do a good approach of Industry 4.0, you have to start to do sensing and collecting of data. If you don't have sensing and collecting of data, it's very difficult to implement Industry 4.0. So first I would say, try to sensing everything of the process and capture the information of the process, and then identify the key variables for controlling the process, temperature, flows, and so on. Once you have that, and once you have that really in control, then you can start doing the smart, the intelligence. So you can start applying machine learning algorithms for controlling, deciding on what kind of control you want to implement, closed loop, intelligent loop, and so on. And then once you control the sensing and the smart, you can start doing the connectivity. Connect all that information that you have of control to other types of analysis that you want to perform. I would say always that you have to first do the registration, then the information, then the analysis, and the decision making. If you don't do it in that way, it's going to be very difficult to implement. And that's something that, from my experience of what we're doing in Mexico, we're doing it wrong. We want to implement big type of systems without having the basics. Well, we are working with, global multinational companies, and they don't have the basic data. So how you can really do models of analysis or models of IA, artificial intelligence, or data science, if you don't have the data, you have to work with it. So I will start doing that sensing, then you apply the smartness, and then you start the connectivity, and then you do build the decision models that you require. That would be my approach. Well, that's what we are doing right now, right?
Thank you, Dr. Arturo.
Any other questions here? No? Okay.
Additional one. Always seems like if we have a discussion, with my colleagues here in Tec de Monterrey, and I want to ask you the same question. Are you a believer of artificial intelligence and machine learning?
Well, my master in science is in artificial intelligence, so I have to say yes. But I will say that the algorithms haven't changed a lot, what I applied when I was studying here my master's degree at Tec de Monterrey in artificial intelligence are the same type of algorithms we're applying right now. So what I always ask myself, what has changed? There are two things that has changed. First, there is more data, but the data requires to be curated. You just cannot use the data, it's there. You have to understand the data and put it on the context, and if you cannot do that, it's going to be difficult to do something. And the second thing, which is important, is the computing capacity. Now we have more computing capacity. Remember, when I was doing my bachelor degree at Tec de Monterrey, I was working with a computer of 64K. Okay, 64K. I don't know if you remember what that, but that's nothing. And we have to implement algorithms because the first task that they ask you in the master degree is to do a chess game. And can you imagine do a chess game with 64K? So it was really a very interesting task. But now that when you have a lot of data, and then you have a lot of high computing capacity, you just have to decide what type of algorithms is really the one you want to apply. And then curate the data, understand the data, and then you can really train all the other AI algorithms. But I am a believer, and we have to take advantage of that, because I always say that these are kind of our knowledge-based system that support decision-making. The decision is going to be made by the human, but the more information you have, and the more information you have with the context, it allows you to have better decisions.
Who did that? Who did they write those algorithms? Who was the person, or who?
Well, there are some of them which are in the literature. You know, there are some authors. We have developed some of our own algorithms, because at the end of the day, all of them are about the same. You know, it's an optimization tool, or it's a decision tool, and so on. So we are, well, the computer scientists. I'm a computer scientist. Okay, that's why I believe in science. So my bachelor is in computer science. So I create those algorithms. So I type down and write down the algorithms. So it's part of what I do as research, together with Pedro Pons and so on. So we have a group who create these new types of algorithms, and we also combine the algorithms so we do a more optimal process.
So it seems like, based on your comment, that human intelligence is always in the highest degree of artificial intelligence, machine learning, and so on. Thank you very much, Dr. Arturo Molina, for your comment.
Hopefully, yes, it's nice. Yes, but again, I mean, you have to take into consideration that that's supporting tools for us, you know, and we have to embrace them. Yes. We don't have to be scared of them. We have to use them so we can really do a better job as engineers, as scientists, and so on. And I think that that's also our job to do it, and to help also the students to do it.
Exactly. So we need to promote human intelligence.
Yes, of course.
In all our activities.
Yes, of course. Yes.
Great news. Thank you.
Okay, we have a question from Dr. Roberto Parra. How will technology impact the transition to a sustainable industry?
Well, I don't think that technology will be the major player here. I believe that we agree on that, Alex, before, is culture. First, we have to establish a culture of sustainability. We have to be a better users of what we consume. So there has to be a sustainable consumption culture. If we change that first, then the other things will come around. But if we don't have a culture of sustainability, it's going to be very difficult that the economics, the environmental, the technologies, and all these things will work out, because we're still going to be a bad consumers. So I will think that we have to work a lot on cultural aspects of the consumption. And we have to be more careful of what we want to consume and how we can consume that. And again, then the technology will allow us to offer us more alternatives of healthy consumption or sustainable consumption and so on. But I will ask everybody, in the institute and also the viewers, is that we should have a sustainable culture first in place so we can really build a better world. If not, technology won't matter, honestly.
Thank you, Dr. Arturo.
So we are just in time. Any other questions? We have 5 minutes. No? No? Okay, thank you. Thank you very much.